Hello, my name is Professor Angelo Rentis. Welcome to the video that accompanies Module 16, Antibiotic Sensitivity. Today we're going to be working on Module 16, Antibiotic Sensitivity. Now, in Module 15, we talked about the fact that there are many antimicrobial agents, and that those antimicrobial agents can be broken down into two smaller groups: the chemical antimicrobial agents and the biological antimicrobial agents. Module 15 evaluated the effectiveness of several different chemical antimicrobial agents, also known as disinfectants and antiseptics, against two bacteria, E. coli and Staph aureus. In the module we're doing today, Module 16, we are going to be looking at biological antimicrobial agents, also known as antibiotics. We're going to evaluate the effectiveness of several antibiotics against E. coli and Staph aureus. On camera, you'll see that there are 8 small dishes, each of these dishes having 2 small absorbent paper discs. The antibiotics that are in these dishes are numbered 1 through 8, and they match the order as found in Lab Module 16. But I'm going to go ahead and read off the names of the antibiotics because I've listed them on the cards underneath the numbers, and I have found that sometimes the numbers that are on the tape here don't show up very well on video. So number 1 is on the far left, and those 2 discs are ampicillin discs. Number 2 dish has chloramphenicol discs. Number 3 dish has erythromycin discs. Dish 5 has penicillin discs. Dish 6 has streptomycin discs. Dish 7 has tetracycline discs. And dish 8 has vancomycin discs. 8 different antibiotics distributed among 8 different dishes. You'll also notice that immediately above the row of small dishes, there are 4 larger agar plates. These 2 plates, the ones that are farthest to the left, have been swab inoculated from an E. coli broth. The 2 plates that are on the right have been swab inoculated from a Staph aureus broth. I've already gone ahead and divided each of the plates into quadrants, and I've labeled the 2 E. coli plates 1, 2, 3, 4, the second plate 5, 6, 7, 8. The 2 plates of Staph aureus, I labeled the first plate 1, 2, 3, 4, second plate 5, 6, 7, 8. Obviously, the numbers assigned to each quadrant are meant to correspond to the number of the antibiotic that will be placed within that quadrant. So in other words, the ampicillin discs will be put in the number 1 quadrants on E. coli and Staph aureus. The number 2 discs, chloramphenicol, will be put on the number 2 quadrants of E. coli and Staph aureus, etc. When I am all done, I will have used up all the discs. So what I'm going to do here is I'm just going to go ahead and transfer several paper discs to the first E. coli plate. I'm going to be transferring discs 1, ampicillin, 2, chloramphenicol, 3, erythromycin, and 4, gentamicin. So I have forceps here. The tips of these forceps have already been sterilized. These discs, of course, are sterile. Getting the disc is going to be a little tricky. So I'm going to take this ampicillin disc and put it in quadrant number 1 of the first E. coli plate. And hopefully you'll notice that I gently push down on that disc to make sure it's sticking to the agar surface. I'm now going to take a paper disc from the chloramphenicol dish, and I will put that on the number 2 quadrant of the E. coli plate. I'll now take a disc from the number 3 dish, in other words, an erythromycin disc, and that will go on the number 3 quadrant. And then finally, the last disc that will go on the first plate of E. coli will be a number 4 disc. Pick that up. Tamp it down, and then replace the cover. So now you can see four discs on the first E. coli plate, quadrants 1, 2, 3, and 4. What I'm going to do off camera is I'm going to finish transferring all these discs to the proper quadrants on the proper plates. When I'm all done, we are going to see that the E. coli that we're working with is being exposed to 8 different antibiotics, and the Staph aureus that we're working with will end up being exposed to the same 8 antibiotics. What we will be able to do is compare the sensitivity of E. coli to each of the 8 antibiotics, and also compare the sensitivity of Staph aureus to each of the 8 antibiotics. What we will do with these plates after I finish putting the discs on all of the quadrants is we'll put the plates in a 37-degree incubator and let them grow overnight. After growing overnight, we then will take the plates out of the incubator and we will examine each quadrant on each plate for zones of inhibition. This is similar to what we did with the disinfectants and antiseptics in Module 15. The difference here is that simply having a zone of inhibition isn't enough to convince us that a particular bacterium is sensitive to that particular antibiotic that is on the disc, causing the zone of inhibition. It turns out that you will get zones of inhibition even in resistant organisms. So over the years, microbiologists have developed tables that indicate the minimum diameter of the zone of inhibition necessary to identify a bacterium as sensitive to the antibiotic. After they incubate overnight, we will have to measure the zones of inhibition for each disc, and then we will need to compare the diameter of each zone of inhibition to a table that will tell us the minimum diameter necessary for the zone of inhibition to indicate sensitivity to the antibiotic. That is the end of my presentation on Module 16, Antibiotic Sensitivity.